We hate the metric system in America.
You hate.
I'm okay with it, you know, but in general, so do you remember what it is in the metric system?
Ohms times meters.
Is it like 2.32? Depends on which one you look at. There's different charts that have different things. 2.82 times 10 to the negative either 6 or 8, right? If it's negative 8, though, it's ohm meters. If it's negative 6, it's ohm centimeters. Right? That's the difference. So a lot of charts, and if you say, what in the hell is he talking about? Go over to discussions and click on what? Sample lab reports and data. Somewhere in here, there's steps. Somewhere in here, there's other things. Maybe it was under. Hit the plus button, yeah. Here you go. Click on this thing. We can do open in a new tab. Whoever messed with this? What's going on? Is the whole computer now frozen?
No, hit F11.
F11? Okay. Oh, there it is. Okay. So go down to, I don't use that F11. I have heard about that. So there's the 1.72. What are y'all telling me about 2.82?
Sorry, I was thinking of aluminum.
Oh, yeah. So you're just kidding. So 1.72. Oh, this pin sucks.
What do we do with 1.68? Isn't this regular copper?
Well,
Are we doing a nil?
we could do either one. So we'll do both. All right, so I'm going to stop using this thing now. See if this is any better. So either 1 point, what was it? 6668? I mean, they're very close. Or 1.72 times 10 to the negative 8. Notice that's ohms meters. And they usually have dashes or dots, but it is, you don't even have to have that. It's ohms multiplied by meters. Just, I have a dot there, but you don't even have to have that. Right? Make sure you recognize that this is not little c, little m. This is not centimeters. This is circular mils, which is a totally different unit system, right? Which sometimes makes people want to flee this particular unit system and use the metric system. And one of the reasons why you don't even see a column, at least on this particular website, of what the resistivity is of copper. So these are two resistivities of copper. They're both right. Now, if you really wanted to get this number from this number to do some interesting dimensional analysis, we did it last night because it was somewhat fun. Not extremely fun, but you could take the 1.68, that is a point, E, negative 8, 1.72, or 1.68, and put ohms, what is that, meters? And we can do a variety of this. Remember this fun dimensional analysis? Someone called it railroad tracks. Is that what they're calling it in high school to make it more fun sounding?
No.
Have you heard that? Railroad tracks? Who's heard of railroad tracks? Well, that might have been one high school from last night, from some remote county in Georgia where the SAT scores are sky high. So anyway, we've got to convert this to ohm circular mils per foot, which means we have to know what in the hell circular mils is. And this is good review because we've talked about it. What is circular mils?
It's the diameter squared.
Yes, the diameter square. We took a square, and this is magnified, right? There's 1 mil, which remember what a mil is. Someone was confused last night. What's a mil? Everybody together now. A milli-inch. It's not a millimeter. Right? A mil is not. I write this down so you won't forget it. Maybe even write it in your notes so you look back at it when you're not so sad and tired and decaffeinated. And you look at this and say, no, they're not the same. This is the metric system. This is the customary system. And wouldn't it be nice if we could just all work with one system? But we don't. You know, we deal with miles per hour versus kilometers per hour. So if we had a square where the dimensions were 1 milli-inch or 1 mil by 1 mil, a milli-inch by a milli-inch, if we square those two things, the square area of that is 1 square mil. Right? But if we think of a circle that's inside, remember doing this? And it's not a perfect circle, it looks like an ellipse or something. But we can't measure of this wire its radius, because we can't cut the wire in half and then figure out what's the radius. It's too small. We can determine its diameter, right, using this tool called calipers. Now these calipers, someone asked last night, what was the manufacturer? And I have no idea. We've had these calipers at this building since this building was here, and before this building was here, it was in the G building. So I don't know how long we've had this. The calipers themselves have these words on it. It has shockproof on it. So I don't know if that means the calipers are shockproof or the company is shockproof. We could experiment with that. I don't think we want to do that. See if it is really shockproof. But there's no manufacturer on here. Oh, there's also some numbers over here. 7366. Have no idea what that means. Now those evening class folks, they're very internet savvy. I'll give out a number like that, or 3050. They start using their iPhone or their doohickeys, and they figure out what it means. In about 2 minutes, they're telling me. So I mentioned these numbers to see if anybody wants to Google calipers, and 7366 is probably a serial number. Who knows? But anyway, we can use this to determine the diameter. What would you expect the diameter of this to be? We don't have that chart up though, right? Where's that chart?